Welcome to this Match 3DX video tutorial. In the previous video we introduced to the different workflows possible with Match 3DX, and today we want to take a closer look to the semi-global matching parameters in Match 3DX. In the beginning we want just to introduce the general functionalities of the parameters, and then we will go into the software and set up the parameters for one of our projects. First, there is one parameter that we can define, which is the minimum number of models. And in this case here, we are looking for images that can see a specific position in our data. So in this example here, we have this castle, and the corner here from the building, we can see these 4 red lines pointing to the same position, and we could take the different images, so for example this upper right image with the lower right image, and we can intersect these two photos when we have correct orientations, and we can generate a point here to measure this corner of the building. And we could also take the lower right and the lower left photo and also make an intersection and get a point. So you get the point. We can have here multiple models all looking on the same position, and the minimum number of models defines how many models at least we have to take that this point will be a valid point in our dense point cloud. And this is very important because of the redundancy. So when we take a look about redundancy, I try a little bit to generalize it. Then we can see here a measurement, for example. So let's say I have these 2 models that I just showed. They're looking on the upper right corner from the castle. Then this cylinder is showing the probability where the measurement will be. So how accurate is my measurement? The length of the cylinder is the height accuracy, and the diameter of the cylinder is the positional accuracy where the point is. So somewhere in this cylinder, this measurement from these 2 photos is positioned. And if I take a second model, then I just look at the same position from a different angle. Again, I have a specific height accuracy here, the yellow cylinder length, and again the diameter is showing approximately the position where my measurement will be. And of course, if I take now multiple models and I combine them, then I can reduce here the probability area. So therefore my measurement will be more closer always to the correct position. And therefore, if I imagine this on a large point cloud, then the point cloud will be less noisy. It will be more accurate for each single measurement. So the standard deviation typically is a value that defines this, will be better, and therefore we will have less errors in our data. We can also here, through redundancy, also evaluate a measurement how good it is, and therefore also have a probability that this measurement should normally be in a good, correct position. Another parameter that we can set in the SGM, in this case, is also the maximum number of models. And in the beginning I would recommend to use for both the automatic. Match 3DX uses for different scenarios different automatic settings depending from the overlap. In case you have a 60-40 or 80-80 overlap, then you have different max numbers and minimum numbers, and you can see here in the table how they are set for Match 3DX. Of course, you can also manually change the minimum number of models and the maximum number of models in case you assume to have better overlap and coverage for the data. Another parameter that you can set in the SGM parameters is the automatic removal of low textured areas. So it's a masking or filtering, so it will analyze each single photo and search for low textured areas, typically sky, what is something with oblique images included, or if you have also perhaps some water areas here in this example. But typically normally for sky is the main purpose, because we don't want to have matching in the skies. If you only have nadir data, so no multi-head system or oblique system, then you can just leave this filtering off. You don't have to switch it on, and then it will not run a masking of your data. The images itself will not physically be changed. The masking is a metadata information and will not physically change your photos. So let's take now a look at the software itself. Meshes will be then in the next video part. For the video tutorial, we have here a very small dataset just to show the functionalities and to have a look at a small portion of the point cloud. So here we have, if we go to Project Edit, our EG Urban Mapper dataset. I have here 12 nadir photos. The system itself is a multi-head system, so we have here a multi-head definition from the multi-head system with the different cameras, where we have a left, a right, a back, a front, and a nadir image. But the multi-head system here is now used for our camera definition, and we also have 12 stations, so each station in this case includes now for our data only the nadir image. Then we have 3 strips, so each strip contains 4 photos, and therefore we have here 80% overlap in the flight direction, so for this here, and then between the strips we have 70% overlap. So please be aware that the photos are online, so in the frames check that the images are on. If not, then you can select all the photos by selecting with Ctrl A or with Shift, and in the edit part you can change the image path, and then you would need to go to training data, images, and nadir folder. It's a folder selection. Yeah, if you go inside, you will not see the photos because it's not an image selection, it's a folder selection here. And then select the correct folder, and then you should see the photos to be online. After this is done, you can save the project, and then we can start from Capture Match 3DX. And in Match 3DX, as mentioned, the commander opens up. I have here a previous one, I will just remove it. And then we can here either add the complete project. This is also possible, so it will then run everywhere where you have enough overlap to process data. Or in our case here, we have defined a polygon, and so I will import the polygon. And this polygon, you can find it in the training data input, and here you find the file 3dx_area, and just open it and say OK, and then this polygon will now be processed, and we will now define our SGM 2.5D parameters for this process here. Therefore we start the edit part, and in the edit part we have to change now the type, and this is now our SGM 2.5D. The FBM CBM, as mentioned in the previous video, is for a digital terrain model where you are more in the classic orthophoto production using the whole thing. Or also if you are not interested into true orthophotos for buildings. So if you just want to have a very dense point cloud for mines where you don't have to true ortho rectify buildings, then the CBM is a very nice option to extract dense point clouds too in a much faster way. Today we are focusing on the 2.5D with the True-Orthophoto. The SGM 3D would then be more for meshes, when you want to have also a lot of information from the facades included. Both is possible, 2.5D and 3D. depending also from our project setup. So today 2.5D for True-Orthophoto production, and then we can choose a strategy, and we have to define the parameters in the strategy for this parameter for this 2.5D extraction, and therefore we open up the strategy window, and in the strategy window we are now setting up the parameters for our project. So I create a new strategy. I call the strategy SGM 2.5D, and it's nadir data, so I will call it here nadir with, in this case, our 80-70% overlap. And for exactly these parameters we will now define it. We have as a type nadir images, so it's an aerial case. We have forward 80% and sidewards we have 70%. And this scenario will also then organize how then the matching and the probabilities are then handled, in this case for our data. By default we will leave automatic for minimum number and maximum number, and just to be aware, this would be then like 2 and 5. This would be the same values, so this would then be, if I manually, I could now say, well, I want to take just from each model, then you have more noise in your data, or you say every third, then you can have gaps because perhaps you don't see everywhere, but the point cloud would still have a better probability. So if completeness is not so much important and not True-Orthophoto, but only the point cloud, this could also be considered. But we will run here with automatic for minimum and maximum, and for the percentage of area coverage we also stick with automatic, which is 95%, but you could also increase this up to 99% if you want. This is just that you want to reach more content in the photo itself, but we will keep this here to automatic. As our main goal is the True-Orthophoto, we will not create a mesh for this part. True-Ortho is always part of the 2.5D SGM process. So we don't have to define any True-Orthophoto settings here. It will always be generated, and we will then show in the next video the output, what we will get in this case. So we say okay, it offers us automatic changes. Oh sorry, I did not save this strategy. I will save the strategy, and also my settings will then automatically be applied. So my minimum grid size will change here, but the grid is not important for us. I will just switch it off. We just want to have the point cloud and the True-Orthophoto. And this is now the last part. We define our output directory, and we will now output here our data into the SGM and here into 2.5D and nadir, and this will then be our output folder where we will have the point cloud and the True-Orthophotos. In the Advanced tab, we can now define until which level we want to process, and this is also important about your RAM on the computer. So if you don't have 16 GB of RAM, then you will only be able to process up to level 2. If you have 16 GB of RAM, then you can run level 1 and level 0 in this case. And we will strongly recommend you to have at least 32 GB of RAM for your computers, or even more. I would recommend 64. My video that I'm doing here on this computer is an older one, and I don't have 16 GB, and we will see when we are now starting the process that Match3dx will inform me and say, look, you want to run on level 0, so you should have at least 32 GB of RAM. But my computer only has 12 GB. Do you want to continue? And of course you can continue, but then it can also stop during the process. Match3dx is a very time-consuming process. If you have large projects, this can take days and weeks. So therefore I would strongly recommend you to have a very good computer configuration to process it. So I will not continue, I will say no, I will just show you with level 1. If I apply this, again, the message comes, look, even for pyramid level 1, you will need at least 16 GB of RAM. Yeah, and this is something we have to be aware that now with the dense point cloud with semi-global matching, you need a very good hardware configuration and also a lot of space. You should have really enough storage space because this can become very large. Typically we say the factor 5 of your input data. So if you have 1 terabyte of input data, then you should at least have 5 additional terabytes for storing all the temporary files and folders that we generate. So for my demo, I will just run here on level 2, so we can then see later on the data structure. Of course, this is not for a production useful level. We want to run on the full potential on level 0, but here for the video, this will be enough for us, and also from time we can then sooner again start to show you about the different outputs. So I apply it, say OK, and then I save it here, and after this is now saved, we can now start the process of the semi-global matching. Okay, I will start now the process. Thank you for watching this video tutorial, and then see you in the next one. Thank you. Goodbye.